Hello my dear students, you are welcome to Walnut School of Mathematics. Sudipsir Math here discussing about inverse trigonometric function. Okay. Today's topic is inverse trigonometric function, that is inverse So today's topic is inverse trigonometric functions. Okay. Suppose sin theta equal to x, we can write theta equal to sin inverse x. Remember it, sin inverse x not equal to 1 by sin x. If sin x whole to the power minus 1, this can be written 1 by sin x, or that is cosec x. But sin inverse x not equal to 1 by sin x. First you have to remember this. Okay. Now for any inverse, it must be bijective. That is 1 1 on 2. That's why for sin inverse x, there will be some domain ranges which follow this. That is, if y equal to sin inverse x, is it possible x equal to 2? X equal to 2 or 3? Is it possible? Is it possible x equal to 2 or 3? No, not possible. So, there are some domain and ranges of this. For sin inverse x, x must lie with minus 1 and 1. Lie between minus 1 and 1. We know for any theta, sin theta lies between minus 1 and 1. That's why the domain of sin inverse x, it must be minus 1 to 1. And range of this, suppose this was the curve of sin x. This is 0, this is pi, this is pi, this is pi by 2, and this is minus pi by 2. Now, in this region, sin x have inverse, that is 1 1 on 2. Otherwise, for this part it may be many 1. So bijective, or for 1 1 on 2, this portion will be its range and this portion will be domain. Let's see the graph of the sin x. Let's see graph of the sin x. We know for sin x, say this is 1 and this is minus 1. So this part up to pi by 2. This is up to pi by 2 and this is minus pi by 2. This is minus pi by 2. Now for this part, this is 1 and this is minus 1 on the y-axis, y dash, and this is on the x-axis, this is x dash. Now this part is for y equal to sin x between minus pi by 2 to pi by 2. And for inverse, for sin inverse, if y equal to sin inverse x, if y equal to sin inverse x, this is pi by 2 and this is minus pi by 2, and so this is 1 and this is minus 1. This is 1 and this is minus 1. So it will be like this. It will be like this up to here, and this will be this. So this is the graph of y equal to sin inverse x. Y equal to sin inverse x. For y equal to sin inverse x, this will be like this. This will be like this. This will be up to 0 to 0. This is 0 comma pi by 2. This is minus pi by 2. This is 1 on the x-axis. X negative. Y-axis. Y negative. So this will be like this for sin inverse x. That is, for y equal to sin inverse x, domain of the, if it is function sin inverse x, then domain of the function minus 1 to 1. For sin inverse x, domain of the function this, and range of the function minus pi by 2 to pi by 2. So for sin inverse x, domain and range this, okay, and that is principal value. This is called principal value. That is, if it is y, then y must lies between minus pi by 2 to pi by 2. Y must be lies between minus pi by 2 to pi by 2, where y equal to sin inverse x. If y equal to sin inverse x, y must be lies between minus pi by 2 to pi by 2. Okay. So for sin inverse x, it is very clear. For sin inverse x, domain this, domain minus 1 to 1, range minus pi by 2 to pi by 2, and this is the principal value. This is the principal value for sin. This is the principal value. Okay. This is called principal value of sin inverse x. Principal value. Okay. For sin inverse x, so it is clear, for sin x curve, it will be like this, but on this part, 1, 1 and 2 are bijective. That's why for this, graph of sin inverse x will be like this. This is 1 and minus 1, and this is pi by 2 and minus pi by 2, like this. So, for sin inverse x, we have to remember domain minus 1 to 1, close bracket, that is included value, range minus pi by 2 to pi by 2 included, that is third bracket, minus pi by 2 to pi by 2. Okay. So this was for sine inverse x. Similarly, for y equal to cos inverse x, for y equal to cos inverse x, y equal to cos inverse x, domain set minus 1 to 1, range 0 to pi, range 0 to pi. Cos inverse x, for cos inverse x, range is 0 to pi. That is principal value, that is principal value must lies between 0 and pi. Principal value must lies between 0 and pi. Okay. So, for cos x, y equal to cos x, curve was like this. Like this. This is at 0 and cos pi by 2 is 0 and here pi, cos pi is minus 1, cos pi is minus 1. So for this part, this is y equal to cos x. Now this is at 0, that will be 1, this is 1 and this is minus 1. This part is 1, this part is minus 1. So cos 0 1 and cos pi minus 1. Remember, cos of this portion is positive. Cos of minus theta equal to cos theta. So cos 0 is 1 and cos pi minus 1. So this part is this part for bijective 1 1 on 2 function. So we will take this part for cos x, y equal to cos x, but for cos inverse x, it will be pi by 2, and say if this is pi and here it is 1 and here it is minus 1, this is 1. So this curve will like this, not a straight line but 1 to like this, minus 1 to 1, minus 1 to 1, it will cut at pi by 2 and this is to minus 1. So minus 1 to 1 and curve will be like this, y equal to cos inverse x. For y equal to cos inverse x, curve will be like this, y equal to cos inverse x, this is 0, this is 0, this is pi by 2 and this is pi. So this is y equal to curve for y equal to cos inverse x. That is, for y equal to cos inverse x, domain minus 1 to 1, range 0 to pi, close bracket, both are close bracket, 0 to pi and minus 1 to 1, that is domain, and principal value must take principal value must take 0 to pi for cos inverse x. Okay. Now, for tan inverse x, suppose y equal to tan inverse x. Tan inverse x. In tan inverse x, x will take all real values. X will take all real values. That is, for tan inverse x, domain equal to any real value. Domain equal to any real value. Domain will take any real value. Range must be lies between pi by 2 comma minus pi by 2 comma pi by 2 open bracket. Open bracket means does not include pi by 2 or minus pi by 2. It does not include pi by 2 or minus pi by 2 because tan pi by 2 undefined, minus pi by 2 also. That's why it does not take take the value pi by 2 or pi by 2 or minus pi by 2. It does not take. That is y lies between minus pi by 2 to pi by 2, and this is called principal value. This is principal value. This is principal value. For tan inverse x, principal value we must take in between pi by minus pi by 2 and pi by 2 open bracket. Okay. Now, for tan inverse x, actually for tan x, curve for tan x, I am discussing both tan x and tan inverse x. For all cases. This is tan x, asymptotes, touch at infinity. This is for tan x. Y equal to tan x, where this is pi by 2 and this is minus pi by 2. This is 0, 1, minus 1, etc. 2, minus 2. It will go to plus infinity to minus infinity for y equal to tan x. Y equal to tan x, that is pi asymptotes. Asymptotes means touch at infinity, one line and curve just touch at infinity. It is called asymptotes. Now 0 means 0 and this part. Now for tan inverse x, it will be different type. For tan inverse x, this is upper part will be pi by 2. This will take pi by 2 and this will take minus pi by 2, and on the x-axis 0, 1, 2, minus 1, minus 2, etc. And this will be asymptotes here like this, pi by 2, and this part will be on minus pi by 2. Okay. So for tan inverse, y equal to tan inverse x. Y equal to tan inverse x. For y equal to tan inverse x, it is asymptotes pi by 2 and at pi by 2 and minus pi by 2. So it will be increases like this and this up to this. So this is the curve of tan x, y equal to tan x, but this is for y equal to tan inverse x. Okay, y equal to tan inverse x. Clear? Now, for cosec, for y equal to cosec inverse x. Say y equal to cosec inverse x. Now cosec does not take the any value between 1 and minus 1. 1 and minus 1. So it will be more than 1 or less than minus 1 type. I am showing the curve. Now for cosec inverse x, domain will be minus infinity to minus 1 union 1 to infinity. Minus infinity to 1, any value minus infinity to 1 and 1 to infinity domain. But range will be minus pi by 2 to minus pi by 2 to pi by 2, but it will not take the value 0. Minus 0, curly bracket 0. So, minus pi by 2 to pi by 2, but 0 is rejected. 0 is rejected. In range, 0 is rejected, and in domain, 1 to 1, minus 1 to 1 is rejected. Minus 1 to 1, no value in domain, or in range, minus pi by 2 to pi by 2, but in between 0 is rejected. Okay? 0 is rejected. That is y not equal to 0. That is y lies between minus pi by 2 to pi by 2, but y not equal to 0. Y not equal to 0. Y not equal to 0 lies between any other value minus 1 to 1, minus pi by 2 to pi by 2, does not take 0, and this is principal value. Principal value. This is for tan inverse x. Okay. Now, for tan inverse x, this is for cosec inverse x. Okay. Now, for cosec inverse x, it is minus pi by 2 to pi by 2, does not take 0. That's why for cosec x, graph will be like this. For cosec x, this is 1, this is minus 1, this is 1, okay, 1, and say this is pi by 2, and this is minus pi by 2, minus pi by 2. So, it will be like this. It will be like this, and from minus 1, this will be like this. For that is cosec pi by 2 is 1, and from 1 it is up to infinity, and cosec minus pi by 2 is minus 1, and this tends to this way. This is y equal to cosec x. For y equal to cosec x, it will be from 1 to, when x tends to 0, that is this y tends to infinity. it tends to infinity. Okay. Now for inverse part, for inverse it will be like pi by 2. This line is pi by 2 y-axis. Obviously y-axis, this is x minus x plus. Y-axis, this is minus. This line is minus pi by 2. This is pi by 2. And say this part is 1. This part is minus 1. This part is 1. And this part is minus 1. So it will be like this. And this is from 1. And this is from minus 1. This is 1. This is minus 1. Like this. Like this. Okay. So this curve and this tends to infinity. This for y equal to cosec inverse x. Okay. So for y equal to cosec inverse x, this and this. This is pi by 2 line. This is pi by 2. This is minus pi by 2 line. But the curve of cosec inverse x, graph of cosec inverse x will be like this. Graph of cosec inverse x will be like this. And for cosec inverse, minus infinity to 1 union 1 to infinity, first bracket, both are first bracket, and we can't touch infinity, so in infinity there should not be any third bracket. Okay, this part, domain. And for range, minus pi by 2 to pi by 2, it will be exclude 0. Okay, for cosec inverse x. Cosec inverse x. Now, sec inverse x. For sec inverse x, domain will be same minus infinity to minus 1. This is includes and union 1 to infinity first bracket. Domain sec x cannot be lies between 1 and minus 1. It cannot be less than 1 or cannot be less than 1 or in between minus 1 and 1. It must be either greater than 1 or less than minus 1. Greater than 1 or less than minus 1. Greater than 1 or less than minus 1. Okay. And its range will be 0 to pi by 2, 0 to pi by 2, but it does not take pi by 2. 0 to pi, it will not take pi by 2. Because sec of pi by 2 is undefined. That's why the range will be 0 to pi, range will be 0 to pi, but exclude pi by 2, exclude pi by 2. So it will not take pi by 2, 0 to pi, third bracket, that is closed interval, but it does not take pi by 2, it does not take pi by 2, and domain in minus infinity to 1, minus 1 union 1 to infinity. Union 1 to infinity. Okay. That is y. That is y lies between 0 and pi, comma y not equal to pi by 2. So this will be the principal value. Principal value. Principal value will be like this: 0 to pi, but does not take y equal to pi by 2. Does not take y equal to pi by 2. So this will be the domain. Domain is this, range is this, and this will be the principal value. This will be the principal value. Okay. Now the graph of sec x. The graph of sec x and sec inverse x. Okay. Now for sec x, if y dashed x dashed, this is 1, this is minus 1, minus 1, and say this is pi by 2 and this is pi. This is pi by 2, that is this is pi by 2 and this point is pi. Say this is pi by 2 and this point is pi. So sec x will be like this, sec 0 1, so it will touch and then grow in this way, this type, okay, this type, okay. And for sec x and for this part from 1 that is from minus 1, this is minus 1, this is the line of minus 1, from minus 1 it will grow this, from minus 1 it will grow this, from 1 it will be this for sec x. But for sec inverse x, this is pi by 2 and this is pi. This is pi, this is pi by 2. And say this is 1, this is 1. So if this is pi by 2 line, from 1, this is from 1, it will be like this, and this is pi by 2. This line is pi by 2. From 1, this will be growth here, from 1, and this is minus 1. Say this is minus 1 on the x-axis, x dash, this is y dash. Now say this is minus 1, so from minus 1 part, this is minus 1, from minus 1 part it will be like this. It will be like this. Minus 1 and this is pi. So from minus 1 part, for y equal to sec inverse x, for y equal to sec inverse x, for y equal to sec inverse x, from minus 1 this way, from plus 1 this way. Okay. From plus 1 this way, from minus 1 this way. This is for sec inverse x. Okay. This is for sec inverse x. Okay. Now this curve is for sec inverse x and for sec inverse x. For sec inverse x, it is clear. Domain minus infinity to minus 1, union 1 to infinity. You have to remember this. 0 to pi range, it does not exclude pi by 2, and 0 to pi, y lies between 0 to pi, but does not include pi by 2. So this is for sec inverse x, domain, range, and this is the graph of sec inverse x, this is graph for sec x. Okay, y equal to sec x, and this is for sec inverse x. Another is cot inverse x. Cot inverse x. Next, for cot inverse x, cot inverse x. For cot inverse x, domain equal to R. For cot inverse x, it can take any value R. Okay. Any value R, range 0 to pi, but does not take 0 and pi. It will not take 0 and pi. That is, y lies between 0 and pi, which is the principal value for cot inverse x. For cot inverse x, principal value 0 to pi, but 0 and pi does not include in between 0 and pi. That's why this is first bracket. This is first bracket, not the third bracket. Okay. Now for graph. What happened in graph? In graph, this is say pi by 2, this is pi, x-axis, x dashed, this is y dashed, and say this is the line of pi. Now for cot x, it will be like this asymptotes. This is y equal to cot x. For y equal to cot x, it will cut at pi by 2. For y equal to cot x, it will cut at pi by 2, and asymptotes x-axis, y-axis at 0 and pi. This is the line of pi, 0 to pi. And for cot inverse x, this is pi. Say this is pi. Okay. And this is positive x-axis 0, x, y, y dashed, minus x, and this is pi by 2, So this curve will be like this. Like this. Okay. Cot inverse x will be like this. This is pi. This is pi by 2. This is pi by 2. And this is pi. Asymptotes at pi and x equal to y equal to 0. That is x-axis. So this curve will be like this. Okay. So this is for y equal to cot inverse x. For y equal to cot inverse x, curve will be like this, and y equal to cot x will be this, and for cot inverse x, domain any real value, it can take any real value. For domain, it can take any real value, but range 0 to pi. Range will be 0 to pi. It does not take 0 or pi. Okay. It does not take 0 or pi. So within this domain and range, we can write sine inverse x. Sine inverse x will be x. For all value. For all value, x lies between -1 and 1. If x lies between -1 and 1, then only we can write sine inverse x equal to x. That is for all time. Cos inverse x equal to x. But in that case also, you have to remember that x must lies between -1 and 1. Then only cos inverse x is x possible. Cos inverse x equal to x possible only for this. But tan inverse x equal to x for r. X belongs to any real number, whatever domain. And also cosec inverse x equal to x in its domain. Whatever domain I have given, for that domain all. For all sec inverse x equal to x in its domain, whatever domain I have given, and cot inverse x equal to x in its domain. Whatever domain given, within that domain only, within that domain only, it is sine of sine inverse x equal to x, cos of cos inverse x equal to x, etc. Similarly, sine inverse sine theta. Sine inverse sine theta equal to theta, but it must follow theta lies between -pi by 2 and pi by 2. Then only it is true. it is true, otherwise not. Okay. So, theta, that is whatever range given, minus pi by 2 to pi by 2. Okay. Similarly, cos inverse cos theta equal to theta only when theta lies between 0 to pi, whatever range given. Remember it? Whatever range given. Okay. Same for all. It will be applicable. For all it will be applicable. Tan inverse tan theta equal to theta. But you have to check the value of theta. Okay. So theta must lies between minus pi by 2 and pi by 2. Whatever given range. And same condition will for cosec inverse cosec inverse cosec theta equal to theta, sec inverse sec theta equal to theta, cot inverse cot theta equal to theta. But you have to check that range whatever I have given. Within that range only this rule is applicable. Within that range. Okay. Within that range only sec inverse or cosec inverse, whatever it is, it will true. Okay. Now, another thing for negative part. Okay. For negative part, sine inverse, negative part, sine inverse minus x will be minus sine inverse x. Sine inverse minus x will be minus sine inverse x for its domain, and cos inverse minus x will be pi minus cos inverse x for its domain. Domain, that is minus 1 to 1. You have to remember minus 1 to 1. Within that value, you can write cos inverse. Within that value, cos inverse minus x equal to pi minus cos inverse x. Okay. Pi minus cos inverse x, tan inverse minus x can be written minus tan inverse x if x belongs to R, whatever its domain. Okay. Cosec inverse minus x equal to minus cosec inverse x minus cosec inverse x. Sec inverse minus x equal to pi minus sec inverse x. Sec inverse minus x equal to pi minus sec inverse minus x equal to pi minus sec inverse x, and cot inverse minus x also pi minus cot inverse x. its domain. But that is, its domain means this is for R or whatever domain is. Within that domain, remember it, cos inverse minus x minus pi minus cos inverse x, cot inverse minus x, pi minus cot inverse x, sec inverse minus x, pi minus sec inverse x within its domain. Okay. Now, another thing, sin inverse x within its domain. Sin inverse x can be written cos inverse root over of 1 minus x square. Sin inverse x can be written cos inverse root over of 1 minus x square, or it can be written tan inverse x by root over of 1 minus x square, x by root over of 1 minus x square, can be written cot inverse root over of 1 minus x square by x, can be written cot inverse root over of 1 minus x square by x, can be written sec inverse 1 by root over of 1 minus x square, and it can be written cosec inverse 1 by x. So, sin inverse x. Sin inverse x can be written cos inverse root over of 1 minus x square, or tan inverse x by root over of, that is perpendicular by base, root over of x by root over of 1 minus x square, cot inverse, this is reverse, root over of 1 minus x square by x, sec inverse 1 by root over of 1 minus x square, or cosec inverse x. Okay, this can be written for sin inverse x to other value. Sin inverse x to other values. Similarly, we can write cos inverse x, same form, cos inverse x can be written sin inverse root over of 1 minus x square, or for tan it will be tan inverse root over of 1 minus x square by x, for tan inverse root over of 1 minus x square by x, for cot inverse x by root over of 1 minus x square, for cot inverse, for sec inverse, that is simply 1 by x, cos inverse x equal to sec inverse 1 by x, sec inverse 1 by x, and for cosec inverse it will be 1 by root over of 1 minus x square. So cos inverse x equal to root over of 1 minus x square, for sin inverse, for tan inverse root over of 1 minus x square by x, for cot inverse x by root over of 1 minus x square, for sec inverse 1 by x, and cosec inverse 1 by root over of 1 minus x square. Okay. Similarly, for tan inverse x, we can write tan inverse x. For tan inverse x, we can write this equal to sin inverse x by root over of 1 minus x square. Sin inverse x by root over of 1 minus x square. Okay. Sin inverse x by root over of 1 minus x square. And for cos inverse 1 by root over of 1 plus x square, that is 1 plus tan square theta cot square theta, that is sec square theta. That's why this. And this will be also plus 1 plus tan square x by 1 plus tan square. Since 1 plus tan square theta equal to sec square theta, 1 plus, that is sec theta, and this is tan theta by sec theta, that will be sin theta. That's why it will be plus. Sin inverse x by root over of 1 plus x square, remember it. Cos inverse 1 by root over of 1 plus x square. And for cot inverse just 1 by x. For cot inverse just 1 by x. And for sec inverse root over of 1 plus x square. For sec inverse root over of 1 plus x square. And for cosec inverse root over of 1 plus x square by x. For cosec inverse root over of 1 plus x square by x. Okay. And also you can write sin inverse 1 by x equal to cosec inverse x. Sin inverse 1 by x equal to cosec inverse x for all restriction. For all, say 1 by x, 0 cannot include, for all x for this domain. For all x belongs to minus infinity to minus 1, minus infinity to minus 1, union 1 to infinity. 1 to infinity. Then only you can do this. Because for cosec inverse x, domain is like this, minus infinity to minus 1. That's why sin inverse 1 by x equal to cosec inverse x. But we must check x lies between minus infinity to minus 1 and 1 to infinity. Okay. Similarly, cos inverse x, for cos inverse x also, cos inverse 1 by x equal to sec inverse x. Cos inverse 1 by x equal to sec inverse x. But we must check for all x belongs to minus infinity to minus 1 union 1 to infinity. We must check this. For use of this, we must check this validity. Okay. And tan inverse x. Remember, tan inverse 1 by x. Tan inverse 1 by x. Tan inverse 1 by x must be written cot inverse x when x greater than 0. If x greater than 0, it will be cot inverse x. Otherwise, it must be written minus pi plus cot inverse x when x less than 0. when x less than 0, 0 cannot take. When x less than 0, when x less than 0, when x less than 0, it will be minus pi. It will be minus pi plus cot inverse x. It will be minus pi plus cot inverse x. Okay. And for greater than 0, cot inverse x will be same as that. Now another formulas. Sin inverse x. Sin inverse x plus cos inverse x equal to pi by 2. Sin inverse x plus cos inverse x equal to pi by 2, where x belongs to minus 1 and 1. X belongs to minus 1 and 1, and tan inverse x plus cot inverse x equal to pi by 2, where x belongs to any real number. Where x belongs to any real number, it will be like this. And sec inverse x plus cosec inverse x equal to pi by 2. Sec inverse x, cosec inverse x, pi by 2, where x belongs to minus infinity to minus 1 union 1 to infinity. Union 1 to infinity. In this value only this will hold. Okay. Clear? Now another formulas. Tan inverse x plus tan inverse y. Tan inverse x plus tan inverse y equal to tan inverse x plus tan inverse y equal to tan inverse of x plus y by 1 minus xy if condition is given if xy less than 1. If xy less than 1, then this will be this. Okay. Now this value will be pi plus tan inverse x plus y by 1 minus xy. Pi plus tan inverse x plus y by 1 minus xy if x greater than 0, if x greater than 0, y greater than 0, and xy greater than 1. X greater than 0, y greater than 0, and xy greater than 1, then only tan inverse x plus tan inverse y equal to pi plus tan inverse of x plus y by 1 minus xy, and this will be minus pi plus tan inverse x plus y by 1 minus xy. This will be minus pi plus tan inverse x plus y by 1 minus xy if x less than 0, y less than 0, and xy greater than 1. Minus pi plus tan inverse of this if x less than 0, y less than 0 and xy greater than 1. Okay. Similarly, it is clear? Similarly, tan x minus tan y. Tan inverse x, tan inverse x minus tan inverse y, tan inverse x minus tan inverse y. For tan inverse x minus tan inverse y, it will be tan inverse of x minus y. This will by x plus y, x minus y by x plus y. If xy greater than equal to minus 1, greater than minus 1. If this xy greater than minus 1, and that will be pi plus tan inverse x minus y by this will be plus, if x greater than 0, y less than 0, xy less than minus 1, xy less than minus 1, x greater than 0, y less than 0, xy less than minus 1, and this will be minus pi plus this, and this will be plus if x less than 0, x less than 0, y greater than 0, x less than 0, y greater than 0, and xy less than minus 1, then tan inverse of tan inverse x minus tan inverse y equal to tan inverse of x minus y by 1 plus xy and pi plus of this or minus pi plus of this. Okay. Similarly, for sine inverse, sine inverse x, for sine inverse x, for sine inverse x plus sine inverse y, for sine inverse x plus sine inverse y, it will be equal to sine inverse x root over of 1 minus y square plus y root over of 1 minus x square. Now, condition is if minus 1 less than equal to x comma y, both 1, x comma y both minus 1 to 1 and x square plus y square and x square plus y square less than equal to 1. Okay? Or if xy less than 0, if xy less than 0 and x square plus y square greater than 1, then only we can write sin inverse x plus sin inverse y equal to sin inverse of x root over of 1 minus y square plus y root over of 1 minus x square. We have to check this condition. We have to check this condition. Otherwise, the value will be pi minus. Otherwise, the value will be pi minus of that value sin inverse x root over of 1 minus y square plus y root over of 1 minus x square. And for this also condition like this, if 0 x comma y 0 less than x comma y less than equal to 1 x 0 less than x comma y less than equal to 1 and x square plus y square greater than 1, x square plus y square greater than 1, and another part will be minus pi minus sin inverse x root over of 1 minus y square plus y root over of 1 minus x square. This will be minus pi minus sin inverse x root over of 1 minus y square plus y root over of 1 minus x square if minus 1 less than equal to x comma y both less than 0 and x square plus y square greater than 1. Okay. For sin inverse x plus sin inverse y, we have to check and use this three formula. According to its the value of x and y. Okay. Similarly, for minus, if sin inverse x minus sin inverse y, so for sin inverse x minus sin inverse y, this formula will be minus, but we have to check it is minus 1 to in between minus 1 to 1 and x square plus y square less than equal to minus 1, or this portion will change minus 1 x comma y lies between minus 1, if minus 1 and 1, then x square plus y square less than 1, it will be true. And another thing, if xy greater than 0, and x square plus y square greater than 1, then it is true. And again also pi minus this pi minus sin inverse x root over of 1 minus y square minus y root over of 1 minus x square if 0 less than x less than 1 and minus 1 and minus 1 less than equal to y less than equal to 0. We have to check for this minus 1 less than equal to y less than equal to 0 and x square plus y square greater than 1. And third condition, minus pi minus of, this will be minus, and for that condition will be minus 1 to 0, and with this 0 y less than equal to 1, 0 y less than greater than 0, less than equal to 1, and x square plus y square greater than 1. Okay, we have to check for sin inverse x minus sin inverse y. Okay, if we use this, we have to check before use this. Okay, similarly for cos. Similarly for cos inverse x plus cos inverse y, cos inverse x plus cos inverse y equal to cos inverse xy minus root over of 1 minus x square 1 minus y square, cos inverse xy minus root over of 1 minus x square 1 minus y square, and we have to check if minus 1 less than equal to x comma y less than equal to 1, x comma y, minus 1 less than equal to x comma y less than equal to 1, and x plus y greater than equal to 0, greater than equal to 0, x plus y greater than equal to 0, greater than equal to 0, and this will be 2 pi. This will be 2 pi minus cos inverse 2 pi minus cos inverse xy minus root over of same 1 minus x square 1 minus y square 1 minus x square 1 minus y square, and condition if minus 1 less than equal to x comma y, minus 1 less than equal to x comma y less than equal to 1, and x plus y less than equal to 0, and x plus y less than equal to 0. So this is for cos inverse x plus cos inverse y. Similarly for minus, that is cos inverse x minus cos inverse y, this will be positive, and validity to be checked. Minus 1 less than equal to x comma y less than equal to 1, and x less than equal to, and x less than equal to y, then this will be that value, this will be that value, this will be that value. Okay, and another thing, this part will be only minus cos inverse. This part will be only minus cos inverse xy. This will be plus xy plus root over of 1 minus x square 1 minus y square and validity will be minus validity to be checked minus 1 less than equal to y less than equal to 0 comma less than equal to 0 comma and 0 less than x less than equal to 1 and x greater than equal to y. X greater than equal to y. Minus 1 less than equal to y less than equal to 0 and 0 less than x less than equal to 1. So this validity we have to check for cos inverse x minus cos inverse y. Okay. For cos inverse x minus cos inverse y, we have to check this. Okay. Another thing, 2 tan inverse x. For 2 tan inverse x, it will be for 2 tan inverse x, it will be tan inverse 2x by tan inverse 2x by 1 minus x square if the condition is if x lies between minus 1 and 1. If x lies between minus 1 and 1 equal to pi plus tan inverse 2x by 1 minus x square if x greater than 1, if x greater than 1 and equal to pi minus pi plus tan inverse 2x by 1 minus x square minus pi plus tan inverse 2x by 1 minus x square if x less than minus 1. If x less than minus 1 minus pi plus tan inverse 2x by 1 minus x square. By using that validity we can prove this all formulas. Okay. Now for 3 tan inverse x, for 3 tan inverse x, 3 tan inverse x, we can write tan inverse 2 tan inverse 3x minus x cube by 1 minus 3x square, 1 minus 3x square, if minus 1 by root 3 less than x less than 1 by root 3, then it will be valid tan inverse 3x minus x cube by 1 minus 3x square if 1 by root 3 less than x less than 1 by root 3 minus 1 by root 3, and this can be written pi plus tan inverse 3x minus x cube by 1 minus 3x square, pi plus tan inverse of this if x greater than 1 by root 3, and this can be written minus pi plus tan inverse 3x minus x cube by 1 minus 3x square if x less than 1 by root 3, less than 1 by root 3. Then tan inverse 3x can be written this way, and for tan inverse 3x, either this or pi minus this or this value you can write. Okay, so for inverse circular function we have to use this type of formulas and according to its conditions. Okay, just giving some example. Suppose given prove that 2 tan inverse x, 2 tan inverse half plus tan inverse 1 by 7 tan inverse 1 by 7 equal to tan inverse 31 by 70. So we will take LHS. 2 tan inverse half plus tan inverse 1 by 7. Now we have to check the condition for 2 tan inverse x. Now half is lies between minus 1 and 1, half. So we can use tan inverse 2x by 1 minus this plus tan inverse 1 by 7. Check x equal to half. Now x lies between minus 1 and 1. X lies between minus 1 and 1. That's why we can use 2 tan inverse x. We can use 2 tan inverse x equal to tan inverse 2x by 1 minus x square, because x lies between minus 1 and 1, minus half that is between minus 1 and 1, that So we can use 2 tan inverse x equal to tan inverse 2x by 1 minus x square only. Now by using this we can get tan inverse, this is 1/4, that is 4 by 3, because this is 1/4, that is 3 by 4, and 1 by 3 by 4, that is 4 by 3, plus tan inverse plus tan inverse 1 by 7. Now we can formula tan inverse x plus tan inverse y. Tan inverse x, tan inverse of x plus y by 1 minus xy. Now simplify it. It will be tan inverse, that is 48 plus 3, LCM 21 cancel, that is 21 minus 4, so it will be tan inverse 31 by 70. Okay. So this way we can do all the sums. Okay, and we have to check and use the formulas. Okay, thank you for watching the video. If you feel, you can subscribe, like, or send comments. Okay, thank you again. Okay, bye.